In this video, I'm going to break down the electrical engineering courses. And I'm going to do this twice. One, based on what most students think, and then second time, I'm going to do it based on what I think. And the course that I've seen most people struggle with is called Signals and Systems. And the follow-up to that course is Communication Systems. And the reason why these courses are challenging to most people is that they are very abstract and everything is kind of invisible and imaginary. And you're dealing with a lot of concepts that you have not seen before that are just like not tangible and just don't make sense from the first time you look at them. In Signals and Systems, you learn about the very famous Fourier transform, and then in Communication Systems, you get to apply it to how we communicate through radios. And what's challenging about that is both of these courses take place almost entirely in the frequency domain. And this is something most students are unfamiliar with and generally are uncomfortable with. Now, the second hardest course, which sits right beneath that one, is Applied Electromagnetics. And this course basically describes the basics of the electric magnetic fields and the electromagnetic waves, basically when you take the electric and the magnetic fields. And on a first glance, you may think this is very simple, like, okay, this is just electric fields, magnetic fields, and electromagnetic waves. But again, because everything is really invisible and abstract, and a lot of the concepts may seem counterintuitive, and the math can be a little difficult, many students tend to struggle with this course. Another concept that a lot of students struggle with is the introduction of transmission lines and matching networks, and the shocking realization that when there is alternating current present, especially at high frequencies, you don't just plug wires into things and call it a day like you would in DC circuits. The third most difficult class, based on my observation, is Engineering Applied Probability and Statistics. And this is where I learn about things like autocorrelations and cross correlations and distributions, and what's a Gaussian distribution, what's a stochastic process. And the mathematics involved is very rigorous and difficult, especially if you don't have a strong background in math, like from high school, and you go in and you take it. You can really struggle. Now, what's funny is that you take all this knowledge that you learn in this probability and statistics course, and you take it and apply it to communication systems. Generally, for example, when you're modeling noise in a communication system. So if you really struggle with probability statistics, and then you struggle with the applied electromagnetics, you struggle with the frequency domain stuff from Signals and Systems, and you put all that stuff together in communication systems, that class is usually a nightmare for a lot of students. And the funny thing is I taught that class twice as a teaching assistant. And although I really enjoyed teaching it and I had a lot of fun teaching it, teaching that class just helped me understand the magnitude of how confusing all this stuff is. Now, the fourth most difficult class I would say is microelectronics. And that's where you start learning about transistors and how to take transistors and build amplifiers with them. And you start having really complicated circuits. Now, the introductory course to that is circuit analysis. And circuit analysis is pretty simple because you basically learn about like resistors, inductors, capacitors, put them together in networks, and you have like a bunch of equations where you solve for like one variable generally. And even if you don't know what's going on, you can still do fine in the class because the math is a lot simpler. Now, the fifth hardest class I would say is embedded systems / VHDL. And I group these things together even though they're different because they kind of are trying to achieve similar things, where in embedded systems, you're working with microcontrollers and you're usually doing some type of programming like Arduino or some type of microcontroller in which you are typing lines of code in software in order to achieve some outcome in hardware. And a very simple example of that is like, for example, writing like a piece of code that makes an LED blink or makes an LED have like a, I don't know, you can make like a clock or an alarm. And this is generally where a lot of students can tinker and build projects, and a lot of senior design projects are usually in this area. Now, VHDL, which is a little more difficult, also aims at the idea of like programming hardware, although you are doing it directly through like logic gates and ALUs and things of that nature. So VHDL is harder, but I would group embedded systems and VHDL as easier than the other stuff because it's like more hands-on, applicable. You get to like program and play around with stuff, which is more fun. And you get to actually see the result and learn from trial and error, versus some of the more difficult classes I mentioned earlier are generally very theoretical, which can make it really hard to understand what's going on. Now, the next class after that is Digital Principles, and generally is an easier class because it's an introductory course to basically how binary systems, how binary numbers work, why we use binary, why computers use binary. This is really like the foundation of like computer engineering, where you start building logic gates and you start doing some basic things, and you can, like, for example, understand how a calculator is built, and you understand how these little binary logic gates are basically the fundamental building blocks of things like processors and RAMs, and basically all the fancy digital circuits that you see in your computer. Now, the nice thing about this course is it starts from absolute scratch and is very logical and does not have like intense mathematics or anything. It's pretty straightforward. So as long as you just keep up Should be pretty easy. The last course here, and in my opinion the easiest, is energy/power systems. And one thing that makes this course easier than the previous ones, even though it's still very theoretical and rigorous, is the simple fact that you're dealing with like large numbers rather than small numbers. For example, with communication systems, you're dealing with like really tiny powers, like picowatts. But with energy systems, you're dealing with like megawatts, gigawatts, and really high numbers. So that makes things easier to visualize. But what actually makes this class easier than the others as well is the idea that energy systems at the end of the day are really all about like efficiency. You're like generating energy from some source and you're trying to transport it through like some type of cable. You're converting power from one source to the other, and you're basically trying to do that as efficiently as possible. And now you take that power and you're distributing it across, I don't know, like a city or a town or whatever, or like a car or something. It's really all about how you efficiently distribute that power. So the fundamental concepts are pretty straightforward. Now, generally, this has been my observation from being a student and a teaching assistant. But for me, actually, if I were to list these courses from easiest to hardest, I would actually flip this table upside down. So power systems, when I took that in undergrad, that class, it was really hard for me to even just show up to lectures and actually understand what's going on, because I was just not very interested in the concept. And on the other hand, I was completely fascinated with signals and systems and communication systems. I remember when I was a sophomore, I would carry around my signals and systems book. It was like this pink book. I would just carry it with me everywhere just because it was so fascinated by it. And that's actually when I came to realize that the definition of easy and hard for most people vary. Some people categorize hard and easy by like rigor, difficulty, or by, I don't know, how hard the concepts are or like how abstract it is. But for some people, including myself, hard and easy really just depends on how enjoyable or fun you find the topic or stimulating. Because yes, even though communication systems or signals and systems or applied electromagnetics, even though this is all invisible, abstract stuff, to me, that's what makes it fascinating. That's what makes it really fun. And that's what makes me curious about it. And actually, when things get really abstract, this is really where you get to be very artistic and you get to kind of shine your own artistic light on things. Because when something's invisible, you get to paint pictures in your own head to visualize it. And that's your own creation. And to me, that makes it a lot more fun. In fact, this stuff, I find it so much fun that I am pursuing a PhD in communication systems. And even though the math can get very difficult and things can get confusing, I still find it very enjoyable. And to me, that makes it easy. And this is a similar case for my PhD advisor, who's also working on similar things. It was actually a huge reason why I decided to pursue the PhD. And I actually made a whole video about why I pursued my PhD in electrical engineering. And I talk in detail about whether it was worth it or not, which you can check out over here.